Carson, looks like it's going to be just an individual lesson today.
Yeah, I don't know where everyone's at.
1 out of 7 attending. That's odd. Wonder if there was an exam in the preceding class or something. Everybody comes from different classes though, so that's not likely.
Yeah, I know we had reliability last week. We had concrete early this week, and we have foundations early next week, but
Yeah.
nothing today.
Well, I see a lot of people watching the lectures on YouTube. They get a lot of watch time.
Yeah, they don't like the midday class.
I guess not. Yeah, well, we offer this class online with the idea that people that aren't in Cincinnati can take it. But this semester we don't have anybody outside of Cincinnati taking it, so we could actually meet in a classroom. Maybe that would be more motivating for people.
Probably would, especially if you didn't record the lectures.
Yeah, right. All right, well, let's get started. Let's see. Today is the 28th, and I was asked to show this slide. We have a forum next week or a symposium, not next week, a week from Monday on the reading day, October 9th. It's in Probasco Auditorium. And if you're interested in talking about structural engineering curricula, then this is something that might be of interest to you. So you can register for the event by clicking on that QR code or navigating to that QR code. And if you're interested in learning more about it, you can contact Maggie or Kara. All right, so here's my schedule for the rest of this week. I'll be on campus tomorrow and available if anybody needs to reach out to me. We lost one already. That's funny. Here's my schedule for next week. So basically the same as this week, with slightly modified office hours on Wednesday. And then I started to put together a schedule looking at the rest of the semester, and we don't have a whole lot of time left. October's wide open, obviously. We don't have any obstructions there. So we have 1, 2, 3, 4, 5, 10 classes in October. But when we get into November, that's where things get pretty broken up. We have a reading day the first Tuesday in October. And then the second week of October, I'm sorry, we have a reading day the first Tuesday of November. The second week of November, we have our exams while I'm traveling to AISC. And then it's Thanksgiving, then the last week of the semester. So when we start to get into October, that's basically the end of the semester for us. So I'm trying to budget the time that we have left and figure out how we're going to spend that and what topics we're going to discuss. So I graded homework number 1. You guys probably saw those grades. I didn't check every number. So if you go through and look at your assignment, you want to make sure that you got the numbers right. You should probably look at the solution that I posted for that. I posted solution for number 2, and I posted homework number 4. So you guys can start working on that. And I haven't graded homework number 2 yet. And when I do, I'm not going to check every number of everybody's assignment. So I'll go through and probably spend about 3, 4, 5 minutes on each assignment, each submission, and then I'll let you guys check it to make sure that you guys are have the right numbers. So, right, that brings us to today. And what I want to start off talking about today are methods of managing output that we get from these analyses and data processing functions in Excel. And then if we have time, we'll start talking about the matrix analysis of beams. But before we do that, I wanted to revisit something that happened on Tuesday. Remember, I was doing the moving load example, and I got some results that I knew were not correct. I could tell by looking at them that it just wasn't what I had expected. And so I thought it might be helpful for you guys to understand the process that I go through when I have to debug a model. I know something's wrong. I don't know what it is. And so usually what I'll do is rather than trying to work with the graphics user's interface, working with SAP 2000 itself, I'll usually go in and look at the source code behind it. I'll go and look at one of these S2K files or a dollar sign 2K file. And for this particular situation, I had one that I knew worked, and then I had one that didn't work. So in this case, it was a little bit easier because I could just put these two text files side by side and compare them and find the anomaly. And so that's what I did. The one that worked was the one that is the file that's shown here on the left. The one that was giving me the odd results is the file that's shown here on the right. And so I just went through and I looked at each one of these cards. A lot of them are identical, and I could just delete them out of the way. The ones that weren't identical, I had to go through and justify and say, well, gee, is it right that they're not the same? And I had more loads in the model that worked than I didn't in the model that didn't work. So I had more cards or more lines in that text file. But eventually, as I went down through here, I found the table of lane definition data, and I was able to figure out, or I was able to see that for some of the members that were defined in my lane definition for the model that I was trying to use in class, they didn't actually have frame objects attached to them. So you might remember that we had member AB was broken up into 2 chunks, member BC was broken up into 5 chunks, member CD was broken up into 2 chunks. And for whatever reason, I don't know how this would happen, but that lane definition was created such that it didn't have any of the member BC objects defined. So once I realized that that wasn't the way it should be by looking at these text files, then I went back and took a look at the user interface in SAP 2000, figured out, hey, something's not right here. I don't know how it got this way, but it did. And so I went in and I corrected it. And then based on that, I was able to get the moment envelope due to the passage of a truck that I expected. So I know a lot of you guys, you're going to end up with, hopefully, you're going to end up with models that don't perform the way that you expect them to. And hopefully, you can do some checks and balances and identify when something isn't behaving the way that it should. And I've got a lecture that I'll present towards the end of the semester on validating models, but and then once you figure out that something isn't behaving the way that it should behave, then how do you handle it from there? Sometimes starting with a new model is the only answer. And if it's a small model, that's not a big deal. But if you have a large model where, hundreds of members or thousands of degrees of freedom, then sometimes working with the graphics user interface just isn't the best solution. And I think there's a generational difference here. Whereas me as an old timer, I'm used to working with the text input, and I can see Carson smiling a little bit. That's okay. Where the newer generation, you guys all love the GUI, and you're going to spend hours and hours in the GUI. But to try and figure out what's going on in there can sometimes be troublesome. It can sometimes take a long time. You have to click on every element. You have to click on maybe going into the edit the tables would be something that's a happy medium between those two. But that's one option, is to go in and output all the information to a text file, and then you can go through it and look at it. Now, obviously, I didn't spend a whole lot of time looking at joint connectivity. I could tell, member AB1 is connected to nodes A and node X1. I could see that in the GUI, but figuring out that path definition was something that was a lot easier for me to figure out using the text file. So, anyways, I'll use this as a segue to the topic of today's lecture. What I'm going to do is jump into SAP 2000, and I have that model open. And so let me go ahead and run it again, and I'll just present the output for that. And what we can do is go in and look at that moment envelope, and let's see, where was that? There it is, and show that. Right. And so it's upside down, but that's not that big of a deal to me right now. So the question then becomes, well, how do we get usable output from SAP 2000? And I showed you, I think, a couple of classes ago where you can go in and use the show tables command under the display menu. And this allows you to output data to the tables. And there's two different table sets. The first one is the model definition. The other one is the analysis results. So if you want to, you can output to Excel all the information that makes up your model. We could, I don't know where it's at in here, but somewhere in here is information that has the lane data, and I could dump that into Excel and edit it that way if I want to. But what I'm really interested in at this point is looking at the output from the model. And so one of the fundamental outputs that we often want are the element frame forces. And I don't often want stresses, but maybe you would want them. Sometimes we want joint output. Usually that's the reactions, and sometimes that's the displacement. Sometimes we want structure output as well, where we can get the base reactions of the structure. And what we can do is then select the load patterns or the load cases that we want, and we can dump all of that information into Excel. And so let me just go ahead and use that as some arbitrary data. It opens up this table editor. There are a number of tables. That's the base reaction. Here are my element forces. Here are the joint displacements and the joint reactions. And so what you can do is you can output these one table at a time, or you can export them all together to Excel. And it takes a minute. And for reasons I don't understand, even though I have a modern version of Excel on my computer, it opens up this old Excel 95 looking type version. And I don't understand why that is, but that's just the way that it works. So if you're going and you're looking at this model, then you want to output the results and do something other than just take a screen snip and paste it into a Word document like you guys did for homework number 2, then this is probably what you're going to be working with. One of the first things you'll note is that these stations are at odd locations, and those are probably not the easiest locations to look at, right? They're station 44, station 44.99. So one of the first things I'm going to do is I'm going to punt on that. I'm going to kill that data. I'm going to go back and I'm going to redefine the output stations that are in this model. And so I have elements that are at many different lengths, right? But I think if we use 2.5 feet as a common denominator, that we would be able to define consistent stationing. So let me do this. I'm going to go to assign frame. I'm going to go output stations, and I'm going to say I want the maximum stationing to be 2.5 feet. And then there aren't any intersections with other elements, so that's not a big deal. Maybe in a frame there would be, but we're just modeling a beam. And there at concentrated load locations, I'm going to deselect that. And normally it's a good thing because you get the maximum values. Maximum moment usually occurs under a concentrated load. But in this case, with a moving load that's going across the bridge, that's going to create a ton of output in that file. So I'm going to go in and use this as my output station definition. I'm going to rerun this, and then I'm going to dump that output back to Excel again, and I'm going to do it quickly. All right, so then we go to display, show tables. I'll just go with the element output this time. I don't really want the joint output so bad, or the structure output. Make sure that that's what I want. Yep. And then I'll export that to Excel. All right, and there is my Excel window. So now the first thing you'll note is that with my output stations, now I have nice even stationing. So if I want to plot the moments and the shear forces, it's a lot easier to work with. And if I want to look at the moments at one point in a beam due to different load combinations or whatever, that's also a lot easier to work with. So what do I have here? I have the frame, I have the station, I have the output case, I have the case type, the step type, axial force, V2 shear, V3 shear, torsion, M2 moment, M3 moment, and then I have the elements and the element stations. So if you're clever with this, you can come in and just do a custom sort on this, and you can get what you want out of it that way. And it works okay for beam type problems. It doesn't work as great for frame type problems where you don't have a linear progression of members across the length of your model. What we can do though is go in and do a custom sort. I know my data has headers, but it's not that useful. The first thing I want to sort based on is often the output case. What load case am I looking at? Then the second thing is the step type. Some of these have max and min values, multiple value outputs for envelopes and range adds. So I'm going to sort based on the step type, which is in column E. Then the next thing I want to sort based on is which frame element I'm looking at any one time. And then finally, the stationing for that frame element. And I think that has it. There we go. So I've got an envelope here. I've got all my maximum values defined from one end of the beam to the other first. And then I've got the minimum values. And then often what I'll do is I'll come in here and I'll insert a blank line in between these different, so that I can navigate up and down through my Excel file using control arrow keys. That makes life a little bit easier. And so sorting like this works. It works fairly well for beam type problems. It's tolerable in other cases. But what I want to do today is use Excel data functions, or show you guys how to use Excel data functions so you can more easily take the output from SAP and turn it into a report that you could use for design, or maybe your peers could use for design. And the real key to this, or the real benefit to these data functions, is that using this approach right here, every time I change the model, I have to go through this process again. If I get through this and then somebody wants to change a beam size, or somebody wants to change the loading or something like that, I have to start over and process this data all over again. But using the Excel data functions that I'm going to show you today, once you have a report template set up, then if something changes in your model, as long as you're not adding members or deleting members or things like that, then you can go in and you can perform a query of that data that comes from the revised model and use it in the existing report. And so that's the real benefit of this approach. So what I'm going to do then is close out SAP so that I don't hog system resources. And I'm going to go in here and launch this PowerPoint. Now, some of you have probably seen some of this stuff already, so apologies, but I know that not everybody in the class has seen all of this. So we'll just start at the beginning and move on from there. So I needed a data set to use as an example, and I thought there is no other data set better than the roster for the Pittsburgh Steelers. So here is the Steelers roster. And I admit that this is a couple of years old at this point. I think if we look down through here, we still have, there's Chris Boswell. I think we still have Ben Roethlisberger in here someplace. I don't see him though. Anyways, so one of the first data functions that I'll illustrate is that's called the match function. What the match function does is it has a value that you're looking for, and you specify an array that you want to look in. And what it'll do is it'll come back and tell you which element within that array is a match for what it is that you're looking for. So what we can do is we can use this match function to find something in an array of cells. So let's suppose that we want to go in with an Excel spreadsheet, and we want to find the record that has the number 56. So let me open up this database. There it is. And we'll go there. There we go. So here's an Excel file. You guys have this Excel file posted on Canvas. So if you want to work along with me, you can. If you want to just watch, that's fine too. But what I want to do is I want to figure out which record number corresponds to the player with a jersey number that matches that. So what I can do is use that match function. I can say equals match. I want to look up this. This is my lookup value. And I want to look in this column here, which represents the uniform number of the player. And then the third entry in there is a tag that means that I'm either going to look for an exact match, I'm going to look for one that is not greater than the value that I specified, or one that is not less than the value I specified. In most cases, you're going to specify a 0, because in most cases, you're probably going to want an exact match. And so if we go and type that in, it turns out that the 11th record is the person who has jersey number 56, and you can see that that's true. This is record number 11. It's Anthony Chiquillo. Don't even know who that is. He's a linebacker from Miami. He was age 26 a couple years ago and had a weight of 255 pounds. All right, so that's the match function. Now, we can also use a VLOOKUP function. That works by letting you look up a value in a table. And it has 4 different parameters that go into it. The value that you want to match in the lookup array, the range of cells that is being searched, the column of the array that you want the value from, and then either a number 0 or 1 for an exact or an approximate match. And this VLOOKUP means that you're going to be looking vertically down through a table until you find a match. Then you go over and you're going to pick a value out of that table from that match. There's also an HLOOKUP that works the opposite way, only you're looking horizontally through the top row, and then you go vertically downwards and pick something out of the row from that. So what we're going to do is we're going to use that. We have our match formula is in cell C5 now. What we're going to do is we're going to go down through and use the VLOOKUP command to find the name corresponding to the 11th record of that table. So I'm going to go in here. I'm going to type equals VLOOKUP parens. I want to look up that number in this table. And so what I'll do is scroll all the way down to the bottom. There we go. And I forgot to hit comma. Let me try that again. Equals V lookup. I'm going to look up that value, comma, and now I'll select this table. I'm using Shift Control right arrow, Shift Control down arrow, and that takes me to the extents of that. Now, the third one is the column index. Now, if I want the name of that person, the name of the person is in the second column. So I type a 2 in there. And then the last one is that I want an exact match. So I'm going to type in a 0. I know it said true or false, but 0 works in there, just like it does for the match. And so that gives me Anthony Chiquillo. Now, if I want to, I can go in here and I could say, okay, who is number 28? Jersey number 28 is the 27th record of this data set, and the name corresponding to that is Mike Hilton. I could go in and say, okay, who is jersey number 54? That is the 23rd record of this data set, and it's Ulysses Gilbert III, right? And so that's how this all works. So what is it, 56 that we started off with? All right, so that's the VLOOKUP. I use that all the time. When I'm doing grade books and things like that, I'll look up an M number out of a table and get the person's name, and then I'll go and figure out what is their homework average from one worksheet and what's the exam average from another work. I use the VLOOKUP function all the time. Okay, we can embed these two as well. So, for example, right now I have a 2-step process. I type in the jersey number of the person that I'm interested in, then I find the record, then I find the name. But I can embed a match within the VLOOKUP command if I want to. And so I can do that this way. I can say equals VLOOKUP, and then what I'm going to do is type in, I want the match for whatever 56 is, and 56 is going to be from that column there. That's going to be a comma 0. I didn't hit I've left a comma out again though, damn it. Comma, there we go. So that represents the lookup value in my VLOOKUP command. And now I need this data set here. I want to specify the second column, and I want an exact match. And so that gives me the name Anthony Chiquillo. So I don't need to know the record number in order to know the name in that case, which makes it a more compact solution. It's a more involved function formula within Excel, but that's okay. We're engineers. We can handle that, right? Let me bring that back just to say. So I'm embedding a VLOOKUP and a match together in one. Then we can go a little bit further as well. Let's suppose I want to have a dynamic, a more dynamic search. So once I look at a jersey number, I want to be able to tell what college they went to, what their weight is, what their age is. And so I can embed 2 different match functions within the same VLOOKUP command. And one of them is going to be a match function, the first one. that looks vertically through the column to find the record number associated with the jersey number. The second one's going to be a match function that works horizontally to look at the headings across the top to figure out which column it is that I want to look in. So what I'm going to do is this. I'm going to say this cell is equal to V lookup. And then I want to go to a match. I want to match the jersey number. And I want to match that in this column here. Yep, and I want it to be an exact match, so I type a 0. Then I hit the comma. Now I need the data set for my VLOOKUP command, and that's that data set there. And now I need to know which column I'm looking in, and this is going to be the second match function. I want to match that within this. And I also want that to be an exact match. And then I need the final 0 in my VLOOKUP command. So I can go in now. I don't need to know the record number. I don't need to know the guy's name or anything. I can just say record number 56. What college did he go to? What is his name? His name is Anthony Chiquillo. What is his position? Right. And I get linebacker. What is his age? Whoops, I spelled age wrong. That's problematic. And so what it's doing is it's using two different match functions. It's using the first match function to look through the column J to find a match for the jersey number. Then it's using the second match function to look through row number 3 to find a match for the headings that are up here. And so that's a dynamic use of embedded matches with VLOOKUP commands. All right, so the VLOOKUP command is quite useful. It works great for a rectangular array of data. The index function is a little bit more dynamic, and because of that, it's sometimes a little bit more challenging to use. It's going to give you the ith and jth value of an array. And if all you have is a vector, one column of numbers, then it's going to give you the ith number. And if you have a row, it's going to give you the ith column in that row. But it's basically a way of looking up the ith and jth element within a group of cells. And so the index function is useful that way because we can use a combination of match functions and index functions and use them to replace the VLOOKUP command that we showed before. VLOOKUP command works great in most cases, but some cases it doesn't work the way we want it to. This is a little bit more of a dynamic approach. So we could go in and we could say, I think I need to go to a different sheet here. Yeah, here's the index function, right? So if I have a row and a column, then I can output this information here. Let me make sure I'm doing what, C7. Yeah. So this is going to be equal to index. And the first thing it wants to know is what the array is. So I'm going to tell it this array here, comma, and then we go back up here. What I want to know is I want the row number 11 and I want column number 2 out of that data set, and it gives me that. And so row number 11 corresponds to Anthony Chiquillo and column number 2 corresponds to the name. So I could go in here and say column number 4, that gives me the position. And so that's the linebacker. I could go in and say column number 5, that's the person's weight. Right. And so that's basically using the index function in the array form.
Wait, Dr. Swanson.
Yeah.
In talking about the index function and match function, one thing that I've done personally is recognizing that the record number that the match function will return is contingent upon like the array you select. So like the match number will be different than the associated row number for an index function if that table is offset from the top of the.
That's right.
That's just one thing I've done wrong.
No, you're absolutely right. And I was careful to avoid that mistake. So when I came in here and I used this match function, the second one, to look at the headings across the top, I was careful to select this cell here as my starting point so that the number that came back from that match function would correspond to the column. It would be easy to just say, okay, I'm going to select cells I3 through N3 and not include that blank cell there. But I did that deliberately to avoid just that problem, because in that case, those data sets are offset from each other. Yeah, I've had that problem too. You have to be careful. All right, let's see, where are we at? So you can use a data function like this as well. We could look up the number by embedding a match function within inside an index. You can embed multiple match functions within inside an index as well. And I think that I'll pass over those and not bother to illustrate those. I think you guys can probably do that on your own. So normally what we do is we use an index match function configured with a 1-column range to provide data with a given criteria. You can use a helper column if you want to, but we can use it in an array form as well, where we use the match function to spit out an array of zeros and ones. And basically, this is a way of writing a query in Excel. I don't know if anybody's familiar with structured query language or SQL servers or things like that, but basically these are more sophisticated databasing programs. Like Oracle is one of the bigger databases that's used. And so when you give your information to Best Buy, when you buy a camera or something like that, they put it into this database. And then they can write a query. They can write a command that goes in and says, all right, give me everybody that's in this database with the last name Swanson. And what they would do is they would write something using structured query language or SQL language, and it would spit out that data. So this form of the index function is similar to that, with the exception that you get basically the first record that matches the criteria that you specify, as opposed to getting all of the records of the criteria that match the criteria that you specify. So this is useful when we go in and look at data that is very rich. So what I'm going to do is go to the third sheet in this seed file that I gave to you guys. And this is basically output from a frame model that I analyzed in SAP 2000. And so what I want to do is I want to be able to go in and pick out the result. And I want to say, okay, I want to specify the member. I want to specify the station. I want to specify the load case. And I want to specify the action. Do I want the axial force, the shear force, the bending moment? And if I type in all of that criteria, I want to be able to get the result that I'm looking for. And so let me see if I can do this and make it work the first time. There's a lot going on here. So this is an index function. So I start off with the index function. And I want to look in this as my data set. Let me go down to the bottom and select it like this. There we go. I don't want the headers at the top. So that's basically the database that I'm querying. All right, and then next I'm going to use this match function, but look at the way that the match function is stipulated. It's actually like this. I want to match a value of 1 within this, and I want to say I want the member number to be equal to this, and I'm going to select A225 through A4, right? So that's going to give me the criteria that I want the member number to be equal to whatever's in that cell. Then I'm going to close that out. I'm going to multiply. And now I want the station number. Oops, I got to do this. Station number to be equal to this guy here, right? And I'm going to close that out. Then I'm going to multiply this. And I'm going to say I want the case that I specify in cell P7 to be equal to the output case here. And then finally, we'll call that good. And what I'm going to specify here is, well, I need a 0. Let's see, comma 0, because I want an exact match. Then I'm going to go in here and do a match for the column. And I want this to be, let's see, I want to match P8 with this. And that I also want to be 0, and I close that out. So basically what it's going to do, it's going to go through this first match function that's in here is going to create a huge array. I've got P5 equals something times P6 equals something times P7 equals something. And when all three of those criteria are satisfied for a given record within that series of arrays, it's going to give a 1. And when in other cases, when 0, 1, or 2 are satisfied, it's going to give a 0 value. So what I'm going to do is use that with the index function, and the index is going to give me the first value that has all three of these criteria that are matched with each other. Now, in order to make this work, you have to hit Control-Shift-Enter. There we go. I don't know if you have to anymore. I think the Excel has gotten better about that, and it knows when you're supposed to do that, so it does it for you. But you used to have to hit Control-Shift-Enter. So if we look at beam BE, for example, station 0, under dead load, if I look at the moment M3, it gives me a value of -40. So I could go beam BE and look at station 24. Under dead load, I get a moment of M3 equal to 3.2. And so that's that value right there, right? I could also select the shear force at that point. So I change this header. That gives me 5.2 for the shear force at that location. And so this is a very dynamic way of going through and examining a set of data from Excel. So the beauty of this is that when you go in and change your model, maybe you tweak the loads, maybe you change a cross section so that the deflections are different or whatever. Now you can just output a new set of data from SAP and you just paste it in here and the query stays the same. So let's suppose that we want to plot a bending moment diagram instead. And so what we can do is we can use this index function. I just copied it. Now I'm pasting it in here. But instead of relying on the station going up here to P6, what I'm going to do is this. I'm going to refer over there to that cell and say O15 instead. I'll hit enter and it gives me -9. So yeah, I've got a shear of -9. And so what I can do then is I can copy this and paste it all the way. Oops, that didn't go where I wanted. I can paste it down through these cells here, but I have to be careful because I need to make sure these references up here are durable. So I'm going to go in and hit F5 a couple of times so that my reference to member BE stays the same. I'm going to hit P7 and hit it's F4, not F5. And then I want to make sure that this stays right, and that is there as well, and my data set is the same. So I got to go through and put those $signs in there to make sure that my searches are over the appropriate ranges. Now what I can do is copy that in and I get the shear, and I can go in and now I can create an XY plot. And so I have a shear force diagram for a set of data coming out of Excel. If I want to go in and plot the bending moment diagram, now I type in M3, there's my bending moment diagram. And so I could go in and modify that if I want to. I can go put a solid line on it. Now it looks more like a bending moment diagram. And I could do this, and maybe I've got more members in here, so I could type in beam CF if I want to. And now I have a bending moment diagram for beam CF instead of beam BE. And it's basically a way of querying the data that comes out of SAP and provides the output in a format that's more usable to you. Now, yeah, so I use this quite a bit, especially if I've got a well-defined, for me, it's example problems. For you guys, it would be projects that you're working on in your engineering office. If I've got a well-defined example problem and I want to go through and create a nice, then I'll take the time to do this. And it saves time in the end when you start going through the iterative process of design, where you first have to specify a member in SAP in order to do the analysis, but then you later find that that member isn't strong enough, or maybe that member is too strong, or maybe you have to change the sections because now you're not meeting drift requirements or things of that nature. And so when you go through that iterative process, then this is a great way of managing output. Let me see if I can find an example. I should have looked this up before class and I didn't have the presence of mind to do that. Yeah, so here's the solution to a homework assignment you guys will get in a few weeks. And it's a brace frame that's several stories tall. And this is the output the way that I formulated it. So I've got moment resisting frames in this. I've got joint output for those. I've got moment resisting. I've got the beam and column output for the moment resisting frames. I've got the joint summary. Then I've got a concentrically braced frame. And so all of this is based on a query of this data that comes out of SAP 2000. And by doing that, I'm able to go in and change things and dynamically update this output without having to go through and spend an hour every time just sorting through the tables to get the member numbers in the right order and the stationing in the right order, et cetera, et cetera, et cetera. All right. And now that I've showed you this, this is where everybody drops the class because that looks like it's a lot of work to do when there's an assignment coming up for that, right? So. All right, so I think I have one more thing in here. There's a more dynamic version of that for copying to. Here's the indirect function as well. Now the indirect function, I don't use this function that often, but it is useful when I do. If you want to refer to data in a different worksheet, then the worksheet name comes into the formula. Like if we go back and look at that, like here, right, MRF output, moment resisting frame output. If I were referring to this from a different sheet, I would have MRF output as a parameter within my function. And it's challenging to reference that dynamically. But if you use the indirect function that's shown here, then you can change the worksheet that you're referencing in a formula. And I'll just let you guys play with that on your own because I don't have an example worked up to show you how to use that, but it can be useful in some cases. All right, so the reason that I'm showing you this now is because when you guys go in and do homework number 4, you're going to get a ton of output from SAP 2000. And if you want to, you can go through and use these databasing functions to sort that data for you. If you don't want to, you don't have to. It's up to you. And for a beam, it's 6 to 1, half dozen to the other. The first time you look at the output, the real benefit of this is when you go back in and modify the model when you find a mistake. Oh, shoot, I forgot to put the moment release in, or oh, shoot, I got the loads in the wrong spot. It's the third, the fourth, the fifth time through the data processing that this stuff becomes more valuable to you. So that's why I'm showing this to you now and before you really start to work on that homework assignment. So one of the things that we did here was that we used the output stations in SAP 2000 to specify where it is along the length of the member that we want. Let me take a moment and show you visual analysis in the analogous situation there. And here's another case where I'm not as familiar with visual analysis, so I kind of know where it's at, but it might take me just a minute to come up with that. It takes a minute to launch too, which is odd. So I think it must be going out on the network and verifying that I'm an authentic user or something. All right, let me see if I have a model here that I could just open up. Single span beam truss example 68. Yeah, let's do this one. All right, so this is a beam. This had the live load on it, and it had HS20 in one span, right? So this is just a beam. And what I want to do is just show you how to specify quote unquote output stations in visual analysis. So if we go into the results view, that gives us this. I think this is an error that says that the members are overstressed. Yeah, but I don't care about that. So let's go back to the results view. Let me close that window out. I'm going to go and select these members. I'm going to go to a member graph like that. Right. So there's my diagrams. Now, what it is I'm going to use in order to get this data out of visual analysis and into Excel is in SAP, we would say show tables. In visual analysis, you actually have to generate a report first, and then you can export that report to Excel or to whatever you want to use with it. So when we go here to the report tab, it has a bunch of things you can put in it. Everything from a bill of materials to a member plan check, section properties. It's down here, the results tables that are most interesting. So we have member forces and member forces detailed. And what you do is you drag this table over to the report, and visual analysis then goes in and picks out the values and puts them in this table. And so what you can do is click on that table, and then you can come over here and you can change how those tables are sorted. So we could come in and make this, let's see, did I click on the right table? Yeah, here we go. We can sort based on the result case, or we could sort based on the member. We can result offsets. That's one thing that we want. So if I want to go in and type in 2.5 feet there, then, I wonder why that, here we go. It didn't work, result offsets. I thought that that was what this value here was. There, it's sorting based on that now instead. As advertised. The yeah, there's a way of changing that, and right now I'm not remembering how, but you can come in and specify where you want these results at. I thought it was right there, but I must be missing something. Modify. Right click. Okay. Well, anyways, after you get the data in this table, then what you do is you right click, you can copy it to the clipboard either as a tab delimited or a comma delimited file. I usually select comma delimited. Then you can come over to Excel. Let me go ahead and specify a new worksheet, and then you can paste it in. It goes in as text, and then you can come up here to the data tab. And from the data tab, you can go text to columns. It's delimited with a comma, and then that pushes all of that out. And that's how you edit it out of visual analysis. I really wish I could remember how to do that. Let me go back and tinker with it for another minute. So we don't care about torsion. We could get rid of torsion out of that table if we wanted to. Oh, okay. It's between 3 and 201. So when I typed in 2.5, it was just outside of the range. So we could put in 5 there if we wanted. There we go. And so now it's giving me five stations along the length of the member. That's what it is. And so I'm not able to specify the feet, but I'm able to specify how many offsets it is, I guess is what it is. All right. So yeah, when you go through, I think one of the there's one problem in homework number 4 that deals with visual analysis, and 2 that deal with SAP 2000. And if you look at the results that I posted for homework number 2, then what you'll see is that here we go. I have it sorted nice and neat. And so the way that I came up with these tables of values is by exporting to a report first, then copying from that report as a comma separated value file, then moving it into SAP 2000 and doing some sorting. Now you'll see in this spreadsheet, I don't have any of the data functions working because this was a simpler beam and I didn't really see the need to do that. But as you get further along with more and more complex problems, you'll probably find opportunity to use that. All right, I don't want to save that file because it was the clean version that I had used. Nope, don't want to save that either. All right, I've got 10 minutes left. Questions on that?
How often do you go the opposite direction? Obviously, you can use Excel for validation of results and to identify changes that need to be made in the SAP model. But how often do you see changes to the SAP model being made first in Excel, then imported?
Well, I'm not actually changing the model from Excel. I'm just using Excel to sort the data and make it easier to use in the subsequent steps of the design. Then I go back and change the model in SAP 2000 and go through that process again. So it's a one-way process at this point.
Okay.
I'm just using Excel to process the data, the data that comes out of SAP. I'm not actually going backwards through that process. You can, but that's quite a bit more advanced. You first need to use Visual Basic, and then you need to log into the application programming interface of SAP 2000. Maybe one of the last classes of the semester, I'll go through and do that and show you guys how to do it. I don't even know if the computers in the computer lab will let you guys do that. They might be locked down to the point where you just can't do that. They tend to limit access to VBA, Visual Basic for Applications, because that used to be a common way that hackers would access computers, is they would send you a Word file or an Excel file that had a VBA script attached to it, and that VBA script would, and so the security associated with VBA has gotten a lot tighter over the past 10, 15 years. But it's very useful that that would be a case where you can actually work that process backwards.
Because I think it's not uncommon for design firms to have, their sizing spreadsheets where they're using spreadsheets that automatically calculate, column sizes or beam sizes. So to then use that information and import it directly into Excel, that just eliminates one variable.
Yep, you could do that. And you can do that without the API. You can, I haven't done this in a long time, so I'm not even going to try and show you on the fly. But you can tell SAP to go and query a spreadsheet for information. So at the beginning of the hour, I showed you those 2 text files that I was using. So rather than referencing the text file, it can actually go out and reference a table set, and it can go in, and if you have the Excel file formatted correctly, it knows where to look for it, and that can be done. And I've not done it often enough to be able to feel comfortable trying to show you how to do that. I would have to think of a context as well. So,
Okay.
All right. What I'll do next is I'm going to work off the other computer here where I can sketch a little bit. I've got just a few minutes, but I can go ahead and get started here on this. And what this is the 4th installment of our matrix analysis discussion. There we go. Let me see if I can draw. Nope. I had this fixed earlier today. There we go. Let's try that. Yeah. Okay. Now I got it. Good. So in semesters past, I waited a while before presenting a lot of the matrix stuff. And so this semester, I've made the choice to present it earlier on. And the reason why is that some of the stuff that we're going to talk about in SAP 2000 would make a lot more sense if you understood the matrix manipulations that go on behind the scenes. And for example, our next modeling lecture is one that deals with property modifiers. The property modifiers actually go in and modify the stiffness matrix that's being used by SAP 2000. But without understanding what a stiffness matrix is, the impact of the property modifiers might be lost on you. So let's go ahead and take another couple of steps forward with respect to our matrix analysis. And what I want to do now is make the leap from modeling trusses to modeling beams and then ultimately frames. And so this is lecture number 4. And what I've done is distributed the first part of it to you because it's a rather lengthy presentation. It's 56 some slides long. And so I gave you, I think, the first 32 slides. And so the process that we use for modeling beams and ultimately frames is fundamentally the same as it is for modeling trusses. We go through the element matrix formulation, the element stiffness matrix formulation. We do that for every element within the model. Then we go through and assemble those element stiffness matrices into a global structure stiffness matrix. We restrain that structure stiffness matrix. We do a matrix inversion process, multiply the inverted stiffness matrix by the loads, and then we get this. So the process is the same with one notable difference, and that difference is that we have different element stiffness matrices for our beam elements than what we had for our truss elements. And so the basic process is this. We're basically going to develop a global stiffness matrix K. We're going to invert it, multiply by the loads, and ultimately solve for displacements within our structure. All right, now the big difference here is that when we look at our elements, a truss element is capable of only axial force, whereas a beam element is capable of vertical translation or transverse translation and bending moment or rotational translations. So when we go through and look at this guy, then this degree of freedom number 1 is actually a displacement delta. Degree of freedom number 2 is actually a rotation theta. Degree of freedom number 3 is another displacement delta, and degree of freedom number 4 is another rotation, theta. Right? So we had axial displacements for our trusses. We had one at the end of each member. Now we have 2 displacements at the end of each beam. One of them is a vertical translation. The other one is a rotation. So when we correspond that to the member end actions, we have a shear at each end and we have a bending moment at each end. So remember that the stiffness coefficient K sub ij is the force at the location and in the direction of degree of freedom I that's required to cause a unit value of the displacement J, while all others are held at 0. So if we want to derive a stiffness matrix associated with this beam element, now note that it doesn't have any axial forces on it, right? We could, if we had an axial force here and an axial force there, then now this becomes a frame element instead of a beam element, but we're going to deal with that separately. We'll just have a beam element now that can't carry axial force, and then in lecture number 5, we'll come back and talk about the combination of the two. So what we're going to do is we're going to impose a displacement that corresponds to the 1 degree of freedom. So we're going to move the left end of the beam upwards by 1 unit. We're not going to let that end rotate. And what we're going to do is figure out what forces are required in order to maintain that displaced shape. In order to push the left end up, we need a force equal to 12 EI over L cubed. And in order to keep that node from, in order to keep the node at the right end from moving upwards, we need another force equal to 12 EI over L cubed pushing downwards. And since I have the arrow pushing up, I put a negative sign on the negative. Yeah, and so it makes sense. Now, in order to keep the left end from rotating, we need a moment there, 6 EI over L squared. And in order to keep the right end from rotating, we need a moment there equal to 6 EI over L squared. Now, these values, some of you have taken advanced analysis. Dr. Rosati teaches it, what is it, 5185 or 6085. This is slope deflection method of analysis is most often used to derive these values. And so if you haven't had that, that's fine. Just take these on faith. I'm not lying to you. If you have had it, then you could go back to your slope deflection formulations and you could derive these yourself. All right, so these 4 values represent the first column within our stiffness matrix for that particular element. We could go through and impose a deformation that corresponds to the number 2 degree of freedom, which means I'm going to rotate the left end of that beam, but I'm not going to let it move up or down. I'm not going to let the right end rotate or move up and down. And so I need a moment of 4 EI over L on the left end and a moment of 2 EI over L on the right end. And then I need these forces 6 EI over L squared and minus 6 EI over L squared to keep the ends from moving. And so that gives me the second column within my element stiffness matrix. And then I could do the same thing again with the right end. So here's a vertical translation at the right end corresponding to degree of freedom number 3. That gives me the third column within my stiffness matrix. And then finally, my 4th degree of freedom, I'm going to rotate the right end of that member by 1 radian. Don't ever say the word degree in this classroom. It's always radians. And then we end up with the 4th column of that stiffness matrix. So that is the stiffness matrix for a beam element with 4 degrees of freedom. And in closing, I had a professor once, John Fleming at the University of Pittsburgh, and back before you could get fired for saying such a thing, he said, I'm not saying this, he said that degrees were man's units and radians are God's units. And so you always work in radians when you go through matrix analysis. He was a very rigid man. You think about inflexible professors, and he was probably the least flexible professor I ever had. But boy, I learned a ton from him. He was a great professor, but nobody liked him except me. All right, that'll do it for today. I'm going to do this. So we'll pick up here when we come back on Tuesday. So hit me up over the weekend if you have questions with your homework. Office hours Tuesday morning at 8:30, and then class again Tuesday after lunch at 12:30. So if I don't hear from you before then, I'll see you on Tuesday. Take care. Oh, I'll stick around for a minute if you guys have questions right now too. So.